Hello, so we're going to go over everything that we've covered so far in this web development course here at Northeastern. So let's just jump right into it. So overall, we have the web development course. And I would say it's split into two main structures that we need. One is the languages that we use in order to make these web apps, and then the frameworks. So like how to turn the languages and the coding that we use into real sites with like multiple pages and a static front end with a backend. So let's just dive into languages here. So the three main languages that we use, is HTML, CSS, and then JavaScript, or like in our case ES6. Okay. So let's dive deeper into HTML specifically. So the things that you need to know are tags, and they are essentially containers that tell the browser what each section would be. So let's say we have a head container, and then this would contain like headers, like H1, H2, and an important thing to know here is you are only allowed one H1. One header as like the main title of the page. We do not want to be confusing people, and it's also for purposes where the site name might need to be read out for someone. Then H1 is very important as like the heading. And then we also have attributes. It gives you a little extra info on each of your tags. So this could be stuff like ID, a group, or a class. Or like a specific behavior. So think of each name tags on like each container, essentially. Okay, so those are the two main things. Let's move on to CSS. So we have selectors, and what CSS does is it converts your HTML into a better looking format. So your HTML will look something like this. Let's say we have words here, maybe we have like a button here, and then what CSS will do is move those components in a way where it looks a lot better. So let's say like this is the same thing as here, and let's say we converted it to move it to the middle, and then we have two on the side, and then maybe we have the button here. So essentially that is what CSS does. It makes your page look prettier. So within that we have selectors, which is how we connect the CSS code to the HTML code, so that it connects and it tells like it tells us where the code is supposed to be changed to look a lot prettier. Examples of this is .class, IDs, and you can even have parent-child relationships, which is what really connects it together. So there are multiple ways to apply CSS. We can do it inline. So we can do a style tag within the HTML code, but best practice for us is to actually create a separate file. So essentially, instead of, let's say this is your HTML file, and this is the CSS file. So you could write, let's say this is your HTML code, and you could write CSS code here too, but it's actually preferred to write your CSS code in a completely another file, just so it's easier for debugging later. And another important thing is to never use IImportant. IImportant, because it makes it harder for debugging, and it basically overwrites most of your code and forces one style to overwrite the others. And then we also have Bootstrap, which we will dive more into later. So Bootstrap. And this is essentially a pre-made CSS tool, and what it does is it allows you to decorate your page in a much better and a much easier way, and it also gives you pre-made CSS components. So let's say you wanted a button or a grid or just like any components. So essentially you'll get a piece of code, and then you can copy that code over to your own code, and then it makes the process a whole lot easier if you were to let's say like you wanted a button in like a certain position. It would make it a lot easier to do that. And we also have a box model, which means essentially every element, let's say on your page, is made up of 4 layers. We have content, padding, border, and margin. And this is just another way of like seeing where you should put your elements. Let's say you wanted to put here, then it would be a lot easier with the box model. Okay, so let's move on to our last component, which is JavaScript. So this really is like making the site like interactive. Like, let's say you wanted your site to have some text, and then you wanted to show that it's like typing and have an animation. You would do that here in the JavaScript section. So we can write functions, and you can write functions like this, the brackets. Oh, those are very bad brackets. Like this. And then we can do declarations and expressions. And these all basically do the same thing, but with just a little bit of like differentiality. Okay, and then we have that's a bad circle. Okay, and then we have the ES6 modules, which split your JavaScript into separate files, import and export. So you're not dumping everything into one giant script, and it just makes things a lot cleaner. We have constants and variables, but generally it is better to use variable just because it's less like once you make a constant, it's constant throughout the entire code base, and it makes it a lot easier to debug later. Variables are also a lot more unpredictable, and which is why we don't use variable anymore. We also have async/await. Essentially, this means that when your code needs to wait for something, like from data or like an outside server, it'll handle that page without freezing the entirety of everything. Okay, and then we also have closures. It's when your function is able to remember variables from where it's created, which lets you make like a private data inside a module pattern. Module. Okay, and then because it is JavaScript, we also have arrays, map, filter, and then we have string literals, which is like template literals that let you like drop stuff into your string. So if you had like something like this, like Z, and then you could replace that later. We also have, like we said before, map. And then we also have ESLint /prettier. This just makes it so that your code looks better, and also for logic. It's like an autoformer, and then it keeps your code consistent within your entire code, if like just to make it easier. And then we also have the DOM, which is it's kind of connected with everything here. It's the browser's live version of HTML. So JavaScript is able to talk to HTML through your DOM. So this is very poorly drawn, but essentially this is what it looks like, is how the connection between JavaScript and HTML. Okay, so let's go over the frameworks that we use in class in order to get these sites up. I'll just move that over. Okay, so there are 2 front ends that we can go over, which is static and then full stack, which is like kind of like a 3-tier client server. Okay, let's just move on to, let's just focus on static for now. Move that up. move that over. Oh, okay, never mind. We'll just write down here. Okay, so static means that there are just files sitting on the server. The browser is able to see, download them, and then what you see is what is written. So nothing really happens on the back end. It just, as the name suggests, it is just static. So static files. And then we have the browser, which is what the user uses to run the window, and it gets the data from the HTML, CSS, and JavaScript files. And then we have Ajax. This lets your page talk to a server in the background so that you can have new data loading without you having to refresh the entire thing. So no refresh. Okay, and then for full stack, for the 3-tier client server, we can think of it as 3 separate layers. So we have the front end, which is what the user sees. And then we have the back end, which is the logic. Like, let's say we wanted to make like a quiz or something on our website, then it would get handled in the back end. And then we have the database, which just stores all the data. Like if you had users and you had their usernames and passwords, it would get stored here in the database. Okay, so this is essentially the 3 tiers that we're talking about. We also have routes, which is, if you think about routes, it's like what leads the user to like a certain part of your site. So we and it connects it with the backend. So get, post, put, delete. These are the routes. So get reads, post creates, put updates, and then delete removes. And then we have the HTTP request, and it's just a structured message from the browser saying, I want like this thing, here are the details. So, okay. And then we have node / express, which lets you turn your JavaScript into a browser. And it is a very light framework, so it makes it easier to set up a server and then handle the routes. There's also listen, which is what starts your server, and then it starts accepting requests on a specific port. Once again, routes are the addresses of your server. Each route points to a URL and then the HTTP method to handle that request. We also have MongoDB. This is handling all the database side of things. So I would put that like closer to here because it is a database that we use to store all user data. And then within that we have the Mongo server, which is the actual database, the real database, running in the background with host, port, and credentials. We haven't gone too much into the MongoDB, but essentially these are the 2 frameworks that we use, and they are connected with each other. But if I were to separate them, that would be it. So this is the higher level overview of everything that we've learned in class, and now I will move on to the next section. Hello, now we're going to move on to the portion where we dive deeper into a specific topic. My topic of choice is HTTP request and how that connects with Express servers, and we will go over that with this. So we have HTML request and silent Express restaurant. So this is a silent restaurant, and we have a customer, a waiter, and a cook. So the roles that these people will have is the customer will act as the browser. The waiter will be the express server, and then the cook will be the database, specifically the MongoDB, which we covered before. Okay, like a real restaurant, the customer never walks into the cooking area, the kitchen area, and they never talk to the cook directly. Everything has to go through the waiter, and then the waiter will relay the information to the cook later. So every request specifically is called an HTTP request, and it's how every single interaction on the web works. So, for example, if we were to load a Instagram or submitting a form, you are submitting a HTTP request, and you are the customer submitting your request to the waiter to give to the cook. Okay, and because this is a silent restaurant, no words are said, and how the customer or you will be able to order is you will have to do it through a paper slip, and that is what we're going to cover next, which is your HTTP request, which is right here. Let me erase that real quick. Yep, okay. So, what is an HTTP request? So, it's like a slip of paper that you hand to your waiter, and it covers all of these things, and we'll just go through them. So method is like, what do you want? Do you want to get, post, put, delete? So do you want to read the menu, create something, update, or delete your order? And then we have a URL and path, which points to specifically what item you're looking for. So let's say I wanted a steak, then that would be the path to, then we would give them the path to the steak. And then we have headers, which includes any dietary restrictions, any allergies, and that essentially covers the metadata portion of this. And then we have the body. Lastly, we have the body, which is any special instructions that you would want to give to your waiter. Like, and this includes the actual data that is being sent, and generally GET requests have no body, but the others do. Okay. So we have this HTTP request that is being sent to the waiter, and the waiter has their own little note card, and they are going to connect their note card to your note card. So the server, since they are the server, they need to know how to handle every single possible request, which is what the routes are. So think of routes as like the waiter's notebook. So if someone wanted water, then the waiter has to go and get water. So if someone does X, you have to go do Y. And Express specifically, a route would look something like this. So we would have app.get, and then let's say they wanted meals specifically, then it would be meals, and then it would just request like this. This is how you would write an express route. Okay, so this specifically means that when someone is submitting a GET request, it goes to meals, and then it will run this function. Res is the incoming order. Rec is the incoming order slip. Res is how you would respond back to that order slip. Yeah, and then we cover this a lot, but if someone has a request and it is not something that the waiter has, then it has to send back something, and what it sends back is a 404 request. You might see this a lot on like sites. If you were to type something and it wasn't a valid site, then it would be like, oh, sorry, 404, we don't have what you're looking for. So that's what it has. And specifically here, we have more of different like GET routes. So in the waiter's notebook, they have to cover everything within it. So again, we have the GET, we have the post, we have the put and delete, which matches up with what we want with the GET, post, put, delete. So based off of that, again, it will give it to the waiter to give it to the cook later. And just to reiterate, 404 error. Okay, so let's bring the food back to the customer. So we covered the waiter, we covered the customer. Now what happens after the waiter talks to the cook, and then it brings back the proper stuff from the database. So after the waiter handles the request, this is the HTTP response. So every response has a status code, and it's a number that tells the client what happened during this request. So usually we have status code 200, which is success. Your food and your request was properly asked for, and it brought it back with no issues. And then we have 404, which is, again, we don't have that, so it's not something that we can do. Or if we had a 500 request, then that would be like, the kitchen is on fire and we cannot help you in any way possible. Please evacuate. Yeah. So the response also carries a body, which includes the JSON data. And in Express, the JSON body is the actual data that happens, and then this would be the call that we would make, which is similar to this one over here, but it shows the status and the response, which again, res for response. So JSON is structured text that both the server and browser can read really easily, and they're able to like manipulate it and work it with any way that they want. Okay, so let's try to just bring everything together, and let's do one full request. So the browser sends a get meals. So that would be step 1. Step 2, and then the waiter, Express, would match it to app.get meals. Then step 3, let me just write, I'll say HTTP requests with Express. Okay, so, and then step 3, the handler functions the queries to MongoDB for the meals. Then the handler calls res.json meals for the response, and then the step 6, the browser receives the JSON and is able to render it because of how they're able to read the JSON file. JSON and renders. Every interaction that you do on the web follows this formula. So if you were to scroll on TikTok, and it would send an HTTP request. If you were to like go on another site, this is what happens every time you send an HTTP request. So we just want to go over quick like common mistakes that happen when we are writing code and we are putting this all together. The most common one is wrong path. This basically is like, the waiter. Like for example, if you were requesting meals, but your path is meal, it would give you that error because it doesn't have it because you are missing that S. And then the second one is you forgot to send a response. So this would be equivalent to your waiter walks away and never comes back. So your handler, for this one, your handler runs, but you never do res send or res.json. So your browser is just kind of sitting there, hanging there, doing whatever because they are not getting a response. And then we have the last one, which is wrong method, which is route doesn't match. So let's say, for example, you yelled at your hostess instead of your waiter because they got your order wrong, even though it's not related. So that would be an example of wrong method. Another example is that you're sending a post. You are sending a post, but your route is app.get, so they don't match. So obviously that would not work. Back to the restaurant example, back to the restaurant example, if the waiter didn't have it in a notebook, or if they walked away, or wrong person, then all of these would be wrong. Hello, now we're going to go into the live coding portion of this. So as you can see, I already have everything set up, all the files and everything in structure, and let's work on server.js. So first things first, we have to import express from express, and then this will be for our front end, and then it's basically our waiter. So the express.json line tells the server to read incoming body request from JSON. So without this line, the request would be unfinished. So I'm just writing that out, and then let's do app.listen, and then we'll do port 3000, and this will be essentially what the server is listening to when we run it locally later. And we will write a message as well, and we'll do console.log, and then this was what will show up when we actually run it. So we'll do restaurant is open on port 3000. Okay, looks good. Now let's move on and import some fake data, because yeah, we need to have fake data. So let's have constant meals, and then we'll have an ID of 1, and then let's say a name, and then let's put pasta, and then we'll also include a price, and we'll put $12. Let's copy that over, and we will add another data, and let me fix that. Okay, and then let's say burger, and let's say the price will be $10. Okay, great. Now we have mock data. Let's move on to the get route. So we will do what we did before when explaining. So we'll do app.get meals, and then we will do that request and response, so rec-res. And then we will return a res status, which again shows us if the request was valid or not. So in our first route, app.get means that we're getting get requests, someone is asking to read our data, and then the path is going to be meals. And again, when a request comes in, express runs this function and passes us two things. So let's move on to the post route. We'll do app.post, and then we'll do meals, and then we'll do that rec-res again. And again, we're going to use the constant, and post is for creating something new. So the new meal comes in through the rec body, and then that's part of the HTTP request, which is why we needed express.json in the first place. So let's do that, and then let's do meals.push new meal, and then we'll do res status 201, and then we'll do .json, and then we'll add a message, and we will add meal added, and then we will make it a new meal. Okay, the post looks good. Let's go over and work on the 404 request that we were talking about before as well. Again, this is when something doesn't properly happen, so let's show a 404. Let's copy the get route, since it's also get, and let's change meals to dessert, and then let's change that status to 404, and let's also add a JSON message, and we will copy that over, and we want to say we don't serve dessert here, is what we want to say. Okay, what is going on in this function? There's a lot of red. Let's see. Meal, new meal. Okay. I see the brackets seem to be right. Let's try deleting that. And then, oh, the brackets look right to me. What is going on here? It's not the semicolon. Let's see. Oh, I see messages spelled wrong. It's that. Property. needs to fake message, and then oh, I see. It's that. Okay, we don't serve dessert here. Okay, let's fix that. Let's put the brackets back. And sometimes like the brackets are really difficult when coding in any language. So let's just fix that and put that back down, and it should be okay. Okay, looks good. Show to 404. And then lastly, we need to do a listener. So let's run that. So let's go to terminal, and then let's do node server.js, and then that listener on top will say restaurant is open on port 3000, and let's go to port 3000. Oh, sorry, wrong port. Let's go to port 3000. And as you can see, it says cannot get because we are not on the correct port. We actually need to go on 3000/meals, and now we can see all the data that we input.